You may think that the Earth is a pretty big place, but it isn't even the biggest planet in the solar system. The biggest planet is Jupiter. The Sun is even bigger than Jupiter. It would take 1.3 million planets the size of Earth to fill the same volume as the Sun. But the Sun is not actually a planet. It is a star, a big and very hot sphere of gas. Apart from the Sun, the largest members of the solar system are the 8 major planets. Nearest the Sun are 4 fairly small, rocky planets: Mercury, Venus, Earth, and Mars. Then there are the 4 gas giants: Jupiter, Saturn, Uranus, and Neptune. These planets are much bigger than Earth, but very lightweight for their size. Now we need your help. Our model of the solar system is incomplete. Can you help us locate each planet's position? Welcome. In this simple model, you'll have to locate each member of the solar system in its correct place. Don't know how? Don't worry. If you touch a shape or a name from the bottom, you are going to get clues. Every name matches with one of the shapes, and you have to discover every pair. Then you will have to drag the name on the bottom of the screen and drop it on its correct position. If you do it right, more information about the solar system will pop up. Good luck. This star is a massive ball of hot gas that gives off light and heat. It's located at the center of the solar system. The Sun provides us with light and heat. Without the Sun, there would be no daylight, and our planet would simply be a dark, frozen world, with no oceans of liquid water and no life. There are more than 100 billion stars in the Milky Way, and there are many different types of stars. Our Sun is of a type called a yellow dwarf. Earth is the only planet on which we know that there have been both plants and animals living. On some planets there is no air to breathe, and on others it is either too hot or too cold. Venus is sometimes referred to as the Earth's sister planet due to their similar size and mass. It's nearly as big as the Earth, with a diameter of 12,104 kilometers. Jupiter is 5 times as far from the Sun as the Earth is, and takes almost 12 years to travel around the Sun. Saturn is the second largest planet in the solar system and is another one of the gas giants, like Jupiter. It takes 29.5 years to travel around the Sun. It's the last of the 4 gas giants, and is 58 times the volume of Earth. Neptune is 30 times as far from the Sun as Earth and takes 165 years to travel around the Sun. It is not very easy to observe since it is always close to the Sun in the sky. Mercury is the closest planet to the Sun, and it's very similar to the Moon. Its surface is covered with impact craters. It is the smallest planet and is made of rock. It is so close to the Sun that it only takes 88 days for it to complete its orbit. And it is much hotter than Earth. Mars takes 687 days to complete its orbit, and the average temperature is -63 degrees Celsius. The hottest planet is Venus, where the average temperature is 460 degrees Celsius. And the coldest is Uranus, which is -220 degrees Celsius. You have completed the level. Press continue to go back to the menu and start other challenges. Seasons are caused because of the Earth's changing position around the Sun. The Earth travels around the Sun in a path called an orbit once a year, every 365 days. As the Earth orbits the Sun, the amount of sunlight that each place on the planet gets each day changes slightly. This change causes the seasons. Not only does the Earth rotate around the Sun every year, but the Earth spins in a circle every 24 hours. This is what we call a day. However, the Earth doesn't spin in a straight up and down manner relative to the Sun. We are slightly tilted. The tilt has 2 major effects: the angle of the Sun to the Earth and the length of the days. For half of the year, the Earth is tilted so that the North Pole is more pointed towards the Sun. For the other half, the South Pole is pointed towards the Sun. Every time a pole is pointed towards the sun, the temperature is higher and days are longer there. Meanwhile, on the opposite pole, the temperature is lower and days are shorter. As the year progresses, the sun will point to different sections of the Earth, changing seasons. But it is always one season on the North Pole and the opposite on the South Pole, because of that tilt. The next challenge is about this. Let's go. Welcome. Here we are going to see how the Earth travels around the Sun in a year. Keep in mind the way the Earth is tilted and how this impacts the seasons. If the Northern Hemisphere is experiencing one season, the Southern is going to be on the opposite one. Knowing that, you'll have to solve the challenges that are going to appear on this screen. Every challenge is about setting the Earth in the right position of its orbit. To do so, you'll have to use the bar on the bottom of the screen. You can see how the temperature changes on the hemispheres by looking at the other screen. When you are sure about the correct position of the Earth, press done. If you are correct, another challenge will appear. Good luck. On the graph, you are going to see how the temperature changes on the hemispheres. At this position, the Earth's northern hemisphere is blue and the southern hemisphere is yellow. That's because the southern hemisphere is receiving direct sunlight at that point. Can you see how tilted the Earth is? In this case, we can say that in the southern hemisphere it is summer, and in the northern hemisphere it is winter. Can you move the Earth to a point where it's summer in the northern hemisphere? Press the done button when you are at the right position. Yes. That's right. At this point, as you can see on the graph, the northern hemisphere is receiving direct sunlight. Now, at this point the southern hemisphere receives sunlight indirectly, since it's colder there. That's why it's winter. As the Earth continues its journey around the sun, the south is going to become warmer and warmer until it reaches summer again. That season is called spring. Can you set the Earth where it's spring on the southern hemisphere? Press the done button when you are at the right position. That's right. The climate becomes warm and the flowers start to blossom. As you already know, in summer, the days are longer. And in winter, nights are longer, and this means the days are shorter. Can you move the Earth to a point where nights are longer on the northern hemisphere? Press the done button when you are at the right position. Exactly. At this point, the northern hemisphere is experiencing winter, so its days are shorter and the nights are longer. Did you notice that on the different hemispheres, the seasons are opposite? So, can you set the Earth on a position where it's summer on the northern hemisphere and winter on the southern hemisphere? Press the done button when you are at the right position. Yes. Summer is usually the warmest and sunniest time of the year. Fruit grows on trees and plants. Young animals grow bigger and stronger. You probably already know that in autumn, the leaves start to fall from the trees. The temperature starts to become lower and lower, until it's winter again. Can you move the Earth to a position where it's autumn on the southern hemisphere? Press the done button when you are at the right position. Perfect. Did you know? Some animals collect food in autumn, before winter comes. So we can tell by the position of the Earth when it's going to be hot on one hemisphere and cold on the other one. And the tilt of the Earth is a very important reason for the difference between the hemispheres. Can you move the Earth to a position where it's winter in the southern hemisphere? Press the done button when you are at the correct position. Yes. Did you know? In tropical places near the Earth's equator there are two seasons, a wet season and a dry season. You have completed the level. Press continue to go back to the menu and start other challenges. In this section we are going to learn about tides and moon phases. They are different topics but are very related. Tides change in a cycle as the moon rotates around the Earth. Throughout the day, the sea level is constantly rising or falling, while the sun and the rotation of the Earth both have some tidal impact. The location of the moon has the biggest effect on the tide. The gravity of the moon causes a high tide. both on the side of the Earth directly below the Moon and on the opposite side of the Earth. Low tides are on the sides of the Earth, 90 degrees away from the Moon. On the other hand, as the Moon moves around the Earth, the Sun illuminates different parts of it during its journey. That's why the Moon's phases happen. As the Moon orbits or circles the Earth, the phase changes. We'll start with a new Moon phase. This is where we can't see any of the lit up side of the Moon. As the Moon orbits the Earth, we can see more and more of the lit up. Finally, when the Moon is on the opposite side of the Earth from the Sun, so the Moon continues to orbit the Earth and we'll now see less and less of the lit up side. And then, the Moon reaches its initial point as a new Moon, and starts a new cycle all over again. So, as the Moon travels around the Earth, both phases and tides are going to change constantly. The next challenge is about this. Let's do that. Welcome. Here we are going to work with the changes on the Moon's phases and its impact on tides. As you can see, on the center of the screen is the Earth with the Moon and its orbit around it. As the Moon travels around the Earth, tides are higher or lower, but its impact is greater based on the position related to the Sun. It's basically like a magnet. Most of the gravitational strength is from the Moon, so that's why its position is so important. But if you add the force from the Sun, you are going to get higher tides. That's why the tides are greater when the Moon aligns with the Sun than when the Moon is perpendicular to the Sun. Besides the tides changing, you are going to be able to see how the Moon changes its phase as you move it around. You will have to complete the challenges that are going to appear in this screen. To do so, you'll have to move the Moon around the Earth using the bar on the bottom of the screen. Every change on the Moon phase or the tides is going to be visible on these other screens. When the Moon is in the correct position, press the Done button. If you do it right, a new challenge will appear. Good luck. If you see the screen on your left, you'll notice that you can't see the Moon. When you start to move it, it's going to show more and more of its surface based on the light from the Sun. This initial state is called new Moon, because it's when the cycle starts. So, it's new when it's completely hidden and full when it's completely shown. Can you move the Moon to its full Moon phase? Press the Done button when you are at the correct position. Exactly. At this point, the Moon is receiving the light directly from the Sun and all its visible area is illuminated. That's why it's called a full moon. As we said before, after the Moon gets to its new phase, we are going to see more and more of it. This thickening is known as waxing, and it's going to end when it reaches the full moon. Can you set the Moon on its waxing phase? Press the button Done when you are at the right position. Perfect. From the new to the full phase, the Moon is going to go through different phases as its illuminated area is bigger and bigger. Now, if you look at the tides, you are going to notice that they are low at this point. Can you set the Moon to a position that will cause higher tides? Press the Done button when you are at the right position. Yes. These are called spring tides. Spring tide occurs when the Sun and the Moon are aligned to combine for the largest tidal range of the highest high tide and the lowest low tide. After the Moon gets to its full phase, we are going to see less and less of it. It is now in a waning mode and is thinner and thinner each night, until it reaches new Moon again. Can you set the Moon to its waning phase? Press the Done button when you are at the correct position. Of course. From the full to the new phase, the Moon is going to go through different phases as its illuminated area is smaller and smaller. As we said, the Moon is waning, so it's going to show less and less until it's not visible again. Like when we started. Can you set the Moon's position on that point where the cycle starts all over again? Press the Done button when you are at the right position. That's right. Did you notice that when the Moon is new or full, the tides are higher than the in-between points? That's because during those phases, the Moon is aligned with the Sun. We said earlier that the spring tides happen when the Moon is aligned with the Sun. And we have been watching the tides go up and down as we move the Moon around. Can you move the Moon to one of the points where the tides are at their lowest? Press the Done button when you are at the right position. Yes, this one is called neap tide. A neap tide is when the tidal range is at its smallest. You have completed the level. Press continue to go back to the menu and start other challenges. Thanks for playing.